Aha, magical.
Start the timer.
Start the timer and go. So if everyone, again, this is an interactive demo, so if you all want to go to this URL here, don't do anything when you go there yet. I don't want to spoil it. And as you're doing this, as we go through this, again, it's going to be a little game. I just want you to imagine to yourself what would be involved in building it yourself. I know you're all hotshot developers, so you could be able to do it quite easily. So here's, hang on, oh yeah, I've got to exit this, don't I? It doesn't quite work. Come on, time's ticking. Okay, so on the left hand side, from your view, there's the actual game itself that hopefully is up on your screens. And on the right-hand side, we have, I'm hoping, it's a live update of everyone's guesses. So the game is fairly simple. It's a bit of Boolean logic, if anyone's familiar with that, and or not implies. And you've got 4 premises, 4 statements asserted to be true. And what you have to do is you have to guess which of the 4 statements follows logically. So if you start guessing now, hopefully the results start appearing on the right-hand side. Instant, yes, look at that, fantastic. Very good. Okay, so what we're demonstrating here, of course, is the fact that we've got real-time updates and everything else. We've got a logic, bit of logic game engine going on there, and so on. So strangely, no one's guessed the right answer. There we go. Someone's guessed 2. Yes, very good, very good. All right, it is a lightning talk, so I'm going to switch back to the presentation and jump back into it again. So what I want to show you now is how easy it is to build the game with Mart Logic. Mart Logic is a data-driven platform that's highly scalable and lots of other great features too. So how does it work? In principle, oh no, that's not good. Okay, well, never mind. On the, we've got the premise there, and what we do essentially is as we insert the premises, we create a triple, which is a little bit of RDF or semantics for those of you who are familiar with it. We insert the triple as true, and then what we do is we break it down into its constituent parts. That's the first step. Then the second step is we have a bunch of Sparkle rules of inference. So things like, if we know that not A, the statement not A is true, then we know that the statement A is false. And we have a bunch of these that essentially encode the various rules of classical logic. And then using Mart Logic's inference engine, we're able to derive the facts that the statement S is false and the statement R is false. Now, those triples aren't stored in the database. They are derived, inferred every time you make that query. So that's the kind of how it works in principle. Let's look at the code. So here's the code. Oh, no, this isn't any good, is it? Can't really see it. Help! Oh, no. All right, I'll tell you what I'm going to do. I'm going to show it in this mode here, because it's hopefully at least show you. There you go, OK. So what we do is we declare a JavaScript class. I'm actually using TypeScript, although it works with JavaScript as well. We annotate it to say it's a class. If you want to, yeah. If you're familiar with Angular 2, it's a sort of idea that they do there. We then annotate that the method is a method, and we're going to expose it as a REST interface. And then what we do is for each of the premises that we're about to load in, we break it down to its constituents, insert triples into the database, create the statement that it's true, and that's our data loaded. Then what happens when you click the buttons to select your answer, you choose which answer it is, 1, 2, 3, 4. It increments that guess, so we're able to draw the graph. And then we pull out the data for that guess. So for example, the guess is it the symbol S is false and R is false? And then what we do is we run the Sparkle query that says, do these triples exist? Now remember, the triples don't exist physically, but they are inferred. So if we're able to get back those triples, then we know that you guessed the right answer. Hopefully it's a bit mind-bending, but hopefully you followed that. Again, what I want you to understand here, though, is how little code is involved. The fact we're able to deploy services, use logical inference, and everything else. What about the actual real-time graphing? OK, well, again, we have a piece of code. We annotate it to say it's an event, and we're going to monitor every time one of these guest documents is updated. We're going to return an observable, which is a sort of nice pattern for asynchronous streams, and we're just going to return that result back out. Under the covers, we use WebSockets to push that out to the client in real time. I think I've whizzed through this, because I always do this. I'm going to go, rah, and I'm worried not to get shut off by music. But the grand finale is, can you do better? Can you write a similar application or have come up with an idea that uses some of the features of MarkLogic? Hopefully some of you will have seen our stall in the bar, and we are holding a coding competition with a cool prize to win. So come see us afterwards.